Hey guys, in this video we're going to take a look at function notation and evaluation. In function notation we are choosing a name for our particular function that lets everybody who looks at the equation know that it is actually a function and not just some relation, okay? The way we name functions is with the f of x notation. F of x is the way you say this this right here, okay, f of x. The f is the function name, and it can be any letter, uppercase or lowercase. It can even be Greek letter. And then the x that's inside the parentheses here, that is the independent value. I'm sorry, independent variable. Independent variable, okay? The independent variable is kind of what drives the function. It's what we generally plug stuff into. The input variable is what's called sometimes. And as I was saying, we use this notation in place of y when we're writing an equation and we want people to know that it is in fact a function. You can also use this with evaluation of functions, because you can plug numbers into this f of x notation where the x is right here that you want to plug into the function itself. So let's take a look at this. Let's look at a couple of examples of evaluating, okay? Let me scoot the page up a little bit. And let's say that I have the function f of x is equal to x squared plus 2x minus 10. So when I'm going to evaluate, I might say something like find f of negative 2. And what that's telling me is that I want to plug negative 2 in for x in my function f, okay? This is especially helpful if you have more than one function that we're working on at one time. This way you can keep them labeled and keep straight which one's which, okay? So what we're going to do is we're going to take the negative 2 and we're going to plug it into that equation. I have an x squared, so that's going to become negative 2 squared plus 2 times negative 2, plug the x in there, minus 10, okay? So we square the negative 2, and then we multiply positive 2 times negative 2, and then we've got that negative 10 to combine there on the end. So I get 4 minus 4 minus 10, and I wind up getting negative 10 for that evaluation. So f of 2 right here winds up being equal to negative 10. Okay? All right, let's look at something different plugged in this time. Okay, I erased part of that to give us a little bit of extra room here. Find f of a plus 1. Now here I'm substituting a plus 1, that whole expression, in for that x, okay? So I'm going to come down here, so I've got a little bit more room. We're going to have x squared, so now x is a plus 1, plug that in, that's going to be squared, plus 2 times x minus 10, scoot up a little bit. If we square that a plus 1, that's a binomial squared, so you will need to FOIL that out, or if you have the product formula for that memorized, you're certainly welcome to use that. Distribute your 2. Oops, almost made that a plus, hang on. Minus 10. Alright, if we multiply that out, distribute this right here, okay, that's going to give me a times a. I'm going to get an a on the outside and an a on the inside, so I'll have 2 a's. And then 1 times 1 is 1, okay? Plus 2a plus 2 minus 10. Combine like terms, a squared plus, I've got 2a's, so 4a. And then I've got a 1 and a 2 minus 10, so 3 minus 10 gives me negative 7. Alright, so our f of a plus 1, if we want to write it a little bit more formally here, is equal to a squared plus 4a minus 7. That's how we plug into just regular equations, whether it's with a number or with an expression. Now, let me show you one other little thing before we leave the evaluation subject. Pull up a new page. We can evaluate with piecewise functions also. Okay, piecewise function is a function made up of pieces of functions, each of which owns its own piece of the domain, okay? None of the pieces overlap, so you may have one piece that owns everything from negative infinity to 2, another piece from 2 to positive infinity, and then, well, that would be a two-piece piecewise function. You can have more than two pieces. You can have 3. This one we're going to look at has 3. So let's say we have a function f of x, and it is equal to 6x when x is less than or equal to 7. It's equal to x squared minus 2 when x is between 7 and 10, and it's going to be equal to the number 13 when x is greater than 10. Okay. Now what you do with this is when you're asked to find a certain a function at a certain x value, you have to figure out which one of those the x that you're given belongs to first. For example, if I were given f of 10, I would need to look up here, and I see two places that 10's mentioned. One's right here, and another is right here. But which one of these two actually has 10 in it? That would be this one with the or equal to, right? So 10 will actually go into the x squared minus 2 part of this. So 10 gets plugged in. 10 is squared minus 2. So that gives me 100 minus 2, which is just a 98. Okay? And then maybe another one, find f of... Well, we really need to talk about what happens if it's over 10. So let's say f of 20. Okay? Now if we look back up here to see which one that's in, it's not less than or equal to 7. It's not between 7 and 10. It's bigger than 10. It's greater than 10, so it belongs to this last one. And you may think, well, what do I do? There's no x to plug the 20 into. Where am I going to put this 20? Well, it just so happens that if x is larger than 10, there's no place to plug x in, so your answer is just 13 automatically, okay? This part would be drawn as a horizontal line if we were actually going to graph it, which means that every single y value is the exact same number as what you have right here, okay? So 13 is the answer there. And if we were to get one more, let's say, just so we have all three of these covered, let's say find f of negative 1. I would use the top because negative 1 is smaller than 7, belongs in the one on the top. So that would be 6 times negative 1, which is negative 6. All right, so that's how we do evaluation of the piecewise function.